Good morning, everyone. So let's spend a little bit of time today talking about gRPC and why it's useful and why we as .NET programmers should at least take a quick look at it. So that's exactly what we are going to do in this video. We're going to take a quick look at gRPC and see how it works. Now, before we jump into gRPC, we know that as web developers, most of us probably worked with web APIs or web services, and the idea in most of these cases is when we are writing web APIs, we are basically writing services where the client is making a call, and while making a call to the service, the client is actually sending some JSON data over an HTTP request. The service is kind of capturing that data, doing something with that data, processing it, and then performing some additional actions, and then returning a response back to the client. And then the client can take the response and do whatever it wants to do with it. But if you think about the overall flow, there is something synchronous about this flow. So if you take a look at the request, when the client sends the request, till the entire request object reaches the server, there is not much the server can do. So it can't begin processing till the entire request has reached the server. Similarly, if you look at the server side, the server is sending the response, but till the time the entire response reaches back to the client, there is not much that the client can do. So the client is basically waiting for the response to come back, and only after it has downloaded the entire response back, that it can start processing the response or doing something with the response. So there is a quote unquote download time that is involved, where there is not much processing that can be done, right? So that's the request response model that we've all grown up with. Of course, the fundamental problem here is that if the response objects are huge, or if the request objects are huge, there is a lot of time both the server and the client are waiting for the response and the request to arrive and get fully downloaded before they can start processing. So as an example, let's say that if one of the responses of one of your web APIs happen to be a huge data set, the client is actually waiting for the entire data set to get downloaded before it can start doing some work with it, right? gRPC is basically one of the attempts at solving this problem. It's Google's take on solving this problem, and gRPC attempts to solve this problem with the concept of streams, where they say that they see data as streams. So remember this problem that we talked about, where the response object is huge and it has to be fully completed and sent to the client, and the client has to actually receive the entire response before it can start doing something with it. What if we start seeing that the data that has to be sent over the response object is a stream rather than an object? And that would suddenly mean that just like you stream your YouTube videos, you should be able to start streaming your response objects back onto the client, and the same is true with the request object also. So gRPC allows you two-way streaming, where it says that you can actually see your request and response objects as streams. That way the server and the client doesn't have to wait for the entire request object to reach, and the client doesn't have to wait for the entire response object to be downloaded before it can start processing it or doing something with it. So that's one of the pain points that gRPC solves. Now, to send and receive data as streams over a wire, standard HTTP doesn't work. We need a specialized way to serialize and deserialize data so that it can be sent over wire in packets as a stream, which is highly optimized for being transmitted as a stream and being downloaded as a stream and being processed as a stream. So think of the stream as XML being sent, but instead of being one fat big XML being transmitted over a wire in one shot, and the client has to kind of finish downloading it before it can do anything with it, think of it as small XML nodes which are tiny and fast and simple to transmit. So that's a proprietary serialization deserialization process that Google has developed, and we're not going to go a lot into the theory of it, but gRPC basically uses what Google calls protocol buffers or protobuf to generate code which then sends data using the specialized stream, which happens to be really fast and allows streaming both for request and response objects. So now that we know that the goal is to stream our request and response objects back and forth, and gRPC uses protobuf to kind of generate code which allows us to create these data streams. And because these data streams are Google proprietary, they can actually use RPC to communicate back and forth between the server and the client. And what that also allows Google to do is it allows them to use proprietary compression algorithms to highly optimize these streams so that they are actually much faster than sending data over standard HTTP using JSON. So with that said, let's quickly jump into a sample project of gRPC and let's see how this all works in real life when we start writing code. So to begin with, let's quickly make a folder called gRPC example, and let's quickly switch into that folder. And once we're here, we're going to make two different projects. We are going to make one gRPC service like a web API but using gRPC, and we're going to make another client which is going to go ahead and consume that service. So let's go ahead and begin by making a folder called server. This is the one that is going to hold the gRPC service. So let's quickly switch into that folder and we'll do a .NET new, and then we'll say gRPC, because remember we said gRPC is baked into .NET now. So we'll quickly type gRPC and we will go ahead and hit enter, and that allows me to directly make a gRPC service without actually having to install something separately or do anything special. So this will basically create a gRPC service for me, and using this gRPC service I will be able to expose endpoints which then the client can go ahead and call. And so once this is done, let's quickly go ahead and do a .NET build, and that will basically go ahead and build the project for me. And once the build is done, I can open the project in Visual Studio Code. Let me go ahead and do that. And now once the project opens, Visual Studio Code will actually go ahead and ask me if there are certain resources that are required to build the project. There are certain assets that are required to build the project. So I'm going to go ahead and essentially click yes, and that will allow VS Code to go ahead and download the required assets. Now with that done, let's quickly jump into the plugins tab to see the kind of support that the tooling provides. So there are these two plugins that I require. One is for linting protobuf files or proto files. Now this essentially right here are proto files that gRPC creates for me, and in order to work with this and in order to allow Visual Studio Code to understand protobuf files, I require these two plugins right here, so that they can give me syntax highlighting and linting and all of that with protobuf. These are essentially two plugins that are readily available in the Visual Studio Marketplace. So you can go ahead and just search for these plugins in the marketplace. Just enter the plugin names, go ahead and search for them and install them. It's pretty straightforward. Now once that's done, let's quickly jump into the files the .NET new gRPC command has generated for me, and one of the important folders to look at here is the Protos folder. Let's quickly open this folder, and there is a sample greet.proto file that has been generated for me. Let's take a quick look at it. Now the way to think about a proto file is think of it as a service specification. It's pretty much like your WSDL file. It defines the specifications of what the gRPC service will look like. So if you look at this specific proto file out here, you will see that it has a namespace, and then there is a package called greet. Inside the package there's a service called the greeter service, which has a say hello method, which basically has essentially a request object and it returns a response object back, and it's a RPC method as we described in our introduction. So the request and the response objects that you see here are kind of elaborated below right here. So each definition of the request and response object is kind of provided here. Now we'll go ahead and quickly copy this file and we'll paste it so that we can create our own proto file. Let's go ahead and rename this to users.proto, right? And now we'll go ahead and start renaming this. So let's begin by renaming the package and call it users. Let's also go ahead and rename the service and call it users, and let's change the method name from say hello to say get users, because I want to get all the users associated. And there is a user request object that this service takes in, and there is a user response object that the service basically returns. And let's go ahead and change the definition of the request object also. Let's call it user request, and instead of taking in a string, it now takes an int32, which is basically the, let's say, company ID for which the users we want to return, right? And let's go ahead and also change the response object out here to user response, and let's go ahead and start naming the attributes that we want. We have the first name, which is the first attribute. Let's have last name as the second attribute. We'll add address as the third attribute, and let's go ahead and add email as the fourth attribute. Right, so the numbers that you see here are basically the order in which these attributes appear in the response object. The order is kind of important for gRPC because it's a proprietary protocol and it's highly optimized, so we have to specify the order of each attribute, right? And gRPC kind of sends that in the order that we specify here. Now let's take a look at this user response object. Remember, we talked about the fact that we don't want to send a single response back. Instead, what we want to send is a collection of users that is streamed to the end user. So let's go ahead and mark this as a stream of user responses, which is then being returned to the client. So that's my proto file. Now as soon as I've saved this file, let's quickly also go ahead and remove the comments from here, and let's clean up the file a little bit. Let's go ahead and save this, and now once this file is saved, we will quickly jump into the csproj file to say that this proto file is now a part of my project. I'm going to copy this greet.proto and I'm also going to paste it and call it users.proto. So now I have the users.proto added to my project as well. Now with that done, all the changes that I need are done. Let me quickly jump into command prompt and let's do a .NET build, and if everything works fine, I should be able to build the project. Let's quickly now jump back to Visual Studio and take a look at the services folder. Right, so inside the services you see here, I have a sample service that has been created for me called the greeter service, which is derived out of the greet.proto file. And you notice here how the say hello method that is specified in the proto file is actually implemented in the service out here. Right, there's a say hello method. So similarly, there is a users.proto file I have created. Now I need to do the implementation of that proto file using a service. So let me quickly go ahead and copy this service file and again paste it and start modifying it as per the requirement. So let's just quickly rename this and let's call this user service, and let's go ahead and start renaming this as per our requirement. So let's rename the service name to user service, and let's change the base class for that to users dot user base. And this user base class is the one that gRPC generated for me when I did a .NET build. And let's go ahead and also rename this to user service, and let's basically go ahead and change greeter service to user service in all the relevant places. Also let's go ahead and rename the constructor to user service, and let's go down and let's go ahead and change the quickly change the method name. Remember, we had a get users method, so let's call that, and let's go ahead and remove this because we don't want a specific response, we want a stream of response back. Our request object was called user request, so let's go ahead and rename it to user request. And remember, our response was a stream of user responses, so let me go ahead and say I server stream writer, and let me create a stream writer of user response objects back, and let's call it a response stream. So now I have a stream that I'm going to send back as my response, right? And I'm going to go ahead and remove these unnecessary parts out of the function, and I'm going to go ahead and start implementing this function. Now example here that we want to show is a list of users that we fetch from the database, right? So let's simulate that. Let's simulate by writing a hard-coded function which goes ahead and returns a bunch of users from the database. So let's quickly go ahead and do that. Let's write a function which returns a list of user responses back, and let's call it get users from DB, and let's accept a company ID. So in real life, when we implement this function, we can actually get all the users for that company. So let's quickly go ahead and create a users object, and I'm going to just create a list of user responses, and to this users object I'm going to add a new user response which basically has a first name of user 1, it has a last name of last name 1, it has an address called actually let me go back and let me call this the last name, and let me go ahead and change this to last one, and let's call the first name as first one. So, and the address we can go ahead and call it address one, and let's call the email as email one, right? So that's the first object that I have added to this collection of user responses. Let me quickly go ahead and copy this line, and let's paste this 4 or 5 times, and let's go ahead and rename the first names accordingly. So let's call this first 2, first 3, first 4, and first 5. Let's quickly go ahead and do the same thing to with last name. Let's call this last 2, last 3, last 4, and last 5. We'll do the same thing with addresses also. So address 2, address 3, address 4, and address 5. And let's quickly do the same thing with email. So email 2, email 3, email 4, and email 5. So that's done, and now let's quickly go ahead and return this specific collection of users back to the calling function. Now let's jump back to the main function and let's start calling this function. So let's say get users from DB, and let's go ahead and pass the company ID that I have in my request object. So let's go ahead and take the request.company ID. Now in real life I will actually use this company ID to get all the users for that company, but now I'm not going to do anything with this right now. I'm just returning a bunch of hard-coded users. So I'm just going to leave this company ID as it is, but I'm still going to pass it so that I can use it when I actually implement that function. So now let's quickly go ahead and start going through every user response in the collection of user responses that I get back from the function. And let's say now that before returning this users back to the end client, I want to emulate a long running process, right? So let's say I want to do some processing on each one of these users before I send it back to the client. So I'm just going to do a task.delay for 1000 milliseconds, which means a second's wait. And because I have an await here, let me also quickly go back up and let me add an async here, right? So my get user method, I'm marking it as async, and let's come back here and let's wait for a second for emulating the processing. And once that's done, let's quickly go ahead and say response stream dot write async, and let's write the current user object back to the stream. So typical idea here is that I am actually processing each request that I get in a collection of data, and instead of waiting for all my processing to complete, I'm doing this await and response stream dot write async to kind of send the data right on the stream before waiting for this for each loop to complete, right? So as I process each user, I am kind of going ahead and returning it back. Now let's quickly jump to the command prompt and let's do a .NET build to build this and see if everything works fine. So with this done, I have a server that is actually streaming the data back as it is processing the data, and now I'm going to go ahead and run this. So let me quickly open a terminal and get this service up and running, so then I can call this service from the client. So let's do a .NET run, and this will actually start running the gRPC service, and then I will be able to call it from the client. The important part here to remember is that this service is not waiting for the entire collection of users to be processed before it returns them. As it's processing every user, it's kind of adding that back to the stream and returning it to the client. So that's the basic idea behind this. Now let's also quickly jump into the client module. So let's come out of this and let's make a quick directory for making the client that consumes this service. Let's switch to that directory and let's do a .NET new console, because the client is a simple console application, or it can be Windows application or anything that consumes a gRPC service, right? So let's go ahead and make a simple console application that basically is going to consume this gRPC service. So once the console application is ready, I'm going to build it, and then I'm going to add some basic packages that I need in order to consume the gRPC service. So one of the packages that I need is called gRPC.net dot client. So I'm going to go ahead and do a .NET add package for that, and this will go ahead and add the package for me. We are also going to go ahead and do a .NET add package for another package which is called the Google Protobuf package to give us support for protobufs inside this project, right? So I'm going to go ahead and do that, and let's also do a .NET add package for gRPC tooling, right? So let's do gRPC.tools, right? So this will go ahead and add some tooling support for gRPC into my client application. So with that done, let's quickly go ahead and build again to see if everything is fine. And it builds all right. So let's open the client project in Visual Studio Code now, and let's take a quick look at it. Now, if you look at the client project, there is not much here, but one of the things, let's go ahead and accept the assets that are required to build this project. And now let's open the csproj file. Now, if you look at the csproj file, these three are already added. What I also need is a reference to the protobuf file, right? Remember, we said that protobuf files are specifications for calling a gRPC service. So they are pretty much like your WSDL files, and just like you require access to the WSDL file in order to call a web service, you require an access to the protobuf file to call a gRPC service. So to give it access, there are multiple ways. You can usually copy the protobuf file and send it over to the client, but because the protobuf file actually is on the same disk with me right now, I'm just going to go ahead and add a dynamic reference to the protobuf file. So let me just go ahead and say protobuf include, and then let me just go ahead and add the path to that protobuf file. The path of the protobuf file is actually in the server folder. Now typically you would copy this and send it to the client, and they would keep it somewhere and reference it, but because we have it on the disk already, we are just going to reference the existing protobuf file, right, rather than copying it and going through the entire process. And we're going to say that the gRPC services that we require on this protobuf side are purely client-side services. So that's your basic reference to the protobuf file, which allows me to now start using this protobuf file. So let me go ahead and do a quick .NET build to see if everything builds all right, and let's then jump into the actual code to kind of start consuming the service. So let's quickly go ahead and change this to calling gRPC service, right? And now let's start writing the code to actually consume the service. The first thing that I'm going to require is a HTTP client handler, right? So let me quickly go ahead and create that. Let me go ahead and say I have an HTTP client handler. Let me create a new HTTP client handler, and let me go ahead and quickly set the right using for this. Okay, so this should allow me to create an HTTP client handler. Now remember, because I am developing locally, I don't have a valid HTTPS certificate, right? So for that, I'm going to say the certificate validation check callback for me is something which allows me to do irregular, non-standard, non-validated certificate. So I'm going to say allow dangerous accept any server-side certificate validator. Now typically you should not be doing this in the production environment, but because we are just trying this out in a development environment, I'm going to go ahead and still do this, and I'm going to just work with the development certificate that I have. Another thing that I'm going to require is an HTTP client. So let me go ahead and do a new HTTP client, and this client is going to use the client handler that I have already created. So with that, let's also go ahead and create a channel, and let's say that this new channel is a gRPC channel for a specific address. And let me go ahead and do using grpc.net.client to kind of do this, and let's go ahead and specify a address. Now remember, we said it was running in localhost 5001, so let's set that address here, localhost 5001, and let's quickly go ahead and say that the channel options, I want to use the HTTP client that I have just created in line 14. So let me go ahead and specify the relevant channel options. So let me say a new gRPC channel option, and let me quickly go ahead and say that I want my HTTP client to be the HTTP client that I just created. So notice the wiring out here, where I'm saying that my channel uses this HTTP client, which uses an HTTP handler, which allows us to accept any server side certificate, and that way I've kind of wired it to use a development certificate. So now let me go ahead and create a client, which is the only thing remaining, and I'm going to say a client is new users. Let me go ahead and set the right using, and let me say users client. So this is the gRPC tooling. When I did .NET build, the gRPC tooling actually generated this users client for me, which wants a channel, so I'm giving it a channel. So let me quickly go ahead and start calling the relevant methods inside the user service. So our method is called get users, if you remember, right? That's the method that is there inside the gRPC service. So let's go ahead and put a try catch block, and let's also put a catch block E. So let's quickly go ahead and do a console.write line, and let's print out any error messages if they occur. So that's done. Let's quickly jump into the code to actually call my method. So remember, we had a request object that our method was accepting called the user request object. So let's go ahead and quickly create a new user request object, and let's say that the company ID here is 1. Right, so I'm going to go ahead and pass this request object to the method which was called get users. So let me go ahead and say using, and let me go ahead and create a call where I'm going to go ahead and say my client dot, and the moment I do a client dot, I should be able to get the get users method here, and I should be able to pass the request object to it. So this is actually going to go ahead and invoke the get users method on the gRPC service, right? So once this method is invoked, remember this method is going to return data in a stream, and I want to process that stream. I want to capture the data as it comes in, right? So I want to deal with the stream that is coming in, and I want to start doing something with the data as it comes in, right? So the stream that I'm going to deal with here is something that I'm going to go ahead and start creating first, right? So I'm going to say while the call dot response stream has a move next, so I'm going to wait for every move next, right, that comes, and it has a cancellation token here, which is a standard threading cancellation token. So let me just go ahead and say that I don't want to use any cancellation token. So let's say cancellation token is none, and let's quickly change the C to capital. Let's say cancellation token dot none. Let's also quickly go ahead and use the right threading using, so that I can go ahead and use a cancellation token of none. And now I'm basically saying that wait for every move next in the stream, and while the stream is giving me data in every move next, I am going to go ahead and start processing the data. And because I have a await here, I'm also going to go ahead and mark my main method as an async, and I'm going to turn the return to a task, and I'm going to go ahead and set the right using here. So with that done, let's quickly go ahead and now start doing something with every item in the stream that kind of comes back to me, right? So every move next results in something coming back to me from the stream. So I'm going to go ahead and say I want to get that item in the current user, and I'm going to say call dot response stream dot current. So that's the move next is going to result in the current changing every time, and I am going to go ahead and say that now I have the current item in the stream. I can start showing it to the user rather than waiting for the entire response to come back, right? So I'm going to say current user dot first name, and let's put a space here, and then say current user dot last name is being fetched from the service, right? So let's go ahead and save this, and so that is done here. So now the idea is pretty simple, right? I am actually calling the method, I am getting the response stream back, I am using that response stream. I am iterating through every object in the response stream, and once that iteration results in a move next to be completed, I have a new current object in the stream. I am taking that current object and I am displaying it to the user. So now typically if you look at it, I would generally have to wait for the entire response object to come back, but now as the data is coming in the stream, the server is kind of returning that data instead of waiting for the entire response object to finish, and the client is reading from the stream and processing each data at a time as it's flowing in through the response object, and it's actually doing something, which is in our case showing it to the end user. So now let's quickly go back to the command prompt and let's fire a .NET build. Let's go ahead and build this, and now we can go ahead and do a .NET run to run this. Now if you go ahead and run this, we get an unimplemented error which says service is unimplemented. Now why is this happening? This is happening because I haven't still exposed my server side endpoint. So let's jump into the server and let's go into startup.cs here, and you notice that each gRPC service that you write needs to be exposed as an endpoint. So let's go ahead and say endpoints.map gRPC service, and let's expose our user service as a gRPC endpoint, and let's go ahead and save this, and let's quickly go ahead and stop running the service, and let's run this again. So now that I have actually gone ahead and exposed the user service endpoint, and I am running this service all over again, now I should quickly be able to jump to my command prompt and I should be able to do a .NET run on the client, and sure enough, you will notice that it will make a call to the gRPC service, and after every second the gRPC service is processing a user. It's taking a second to process the user. We had simulated that, and it's returning the user back, and the client, instead of waiting for the entire response to come back, every second it's taking the object that it's getting back on the stream and it's showing it to the end user. So I don't have to wait for the entire response object to kind of flow back, right? So if you notice out here, this task.delay was what we had put in to simulate a wait, and then instead of waiting for the entire response to come back and doing a return after the for each loop is over, right? So this is where you would have the return typically in a web API, but because this is streaming, as I process each request, I'm actually able to stream this back and write this synchronously on the stream, and then the client is actually quickly taking that, listening to the stream, and every time it gets an object on the stream, it's doing a move next, and it's actually going ahead and processing the response as it comes in through the stream, and it's showing it to the end user. So that's a quick overview of what streaming looks like using gRPC. Now remember, we have only done one-way streaming here where the response object is being streamed, but important to note that gRPC actually supports two-way streaming. So just like you streamed the response object, if your request objects are huge, you can also stream those. But this was kind of a quick overview to show you how gRPC basically works. So the essential idea is that you start by creating a proto file, which is your gRPC service specification, where you define what your gRPC service will look like. Then you go ahead and implement that proto file using a gRPC service, actual gRPC service, where you create an RPC method that can accept request and response objects. You define those request and response objects. Now those request and response objects can actually be streams. Once you have created those services, you kind of publish them and you run them, and once those services are running, you take your proto files and give them to the clients. Then you go ahead and create a client using that specific proto file. Once you have the right reference to the proto file in your csproj file, the tooling actually generates the client side stubs for you, where you can actually go ahead and call the method, right? And then you basically have the basic wiring for the HTTP client, where you actually start making the call, and when you make the call to the gRPC service, the response kind of comes back to you essentially as a stream, and as the response is coming back, as each object is getting added on the stream, instead of waiting for the entire response to come back, as the response flows in through the stream, you can process each item in the stream and you can start doing something with it instead of having to wait for the entire response object to come back. So that's a quick overview of what gRPC looks like and how it can make you efficient as a .NET programmer, especially in cases where you have huge request and response objects flowing back and forth. There are a lot of articles out there which say that because of the fact that gRPC uses proprietary compression algorithms, gRPC is faster than a web API. Some of the articles actually seem to suggest that it's 8 to 10 times faster than a standard web API that's written over REST, returning and sending JSON data. So that's your quick overview. I'll also paste a link to some of those articles on the description section so that you can take a look at it and evaluate if gRPC is useful for you or not, and see if you want to use it in your next project or your next assignment. But that's a quick overview of what gRPC looks like. Thanks for watching. Bye bye.